So let's go ahead and finish up question 4, the last part of question 4, which asks us to find the probability that the number of U.S. adults who have very little confidence in newspapers is less than 4. Okay, so on our binomial calculator, you select the less than symbol, type in the number 4 to compute, and we get our corresponding probability, and we're going to go ahead and round that to 3 decimal places. So 0.071 would be the answer. So question 5 is very similar, so I'm going to go ahead and skip it. Okay, same with question 6. So I'm going to go to question 7. Alright, in question 7 it says 33% of college students say they use credit cards because of the rewards program. You randomly select 10 college students and ask each to name the reason he or she uses credit cards. So we want to find the probability that the number of college students who say they use credit cards because of the rewards program is A, exactly 2, B, more than 2, and C, between 2 and 5 inclusive. And it says, if convenient, use technology to find the probabilities. And that's exactly what we're going to do in this problem. Okay, so you can see that this is a binomial experiment. Okay, the fixed number of trials is 10. Okay, so 10 randomly selected college students. And the fact that the college students are randomly selected means that the response of one student will not affect the response of the other students. Okay, and the probability of success is the same, so we're assuming that for each student, they have a 33% chance of saying that they use a credit card because of the rewards program. Okay, and even though the problem doesn't say it, right, we are classifying the responses of the students into 2 categories, right, success and failure. Right, so we are only interested, right, in counting the number of college students who say they use credit cards because of the rewards program. Right, and if a student gives another response other than that, right, that's considered a failure. Okay, so there, right, so once again, there are only 2 outcomes, right? So either the student uses the cards because of the rewards program, or they don't. Okay, and then the random variable is counting the number of students out of the 10, right, who say they use credit cards because of the rewards program. Okay, so let's answer part A, right? Let's find the probability that exactly 2 out of the 10 say they use the credit cards because of the rewards program. Okay, so our probability of success, which is 33%, right, needs to be converted into a decimal. You can easily do that on a calculator, so 33 divided by 100. Okay, so I want to convert 33% to a decimal, so 33 divided by 100, 0.33. Okay, so that's our probability of success. And the number of trials is 10, right, the 10 college students that we select. So N is 10, P is 0.33. Okay, so the probability of success should always be entered as a decimal, okay, into this binomial calculator. Okay, and remember in part A, we're asking for the probability that exactly 2 out of the 10, right, use credit cards for the rewards program. Okay, so you change this to an equal sign, so exactly means equal to. Okay, and then click compute to get that probability. Okay, so it gives you the probability here. Alright, and then it shows you a graph of the distribution. Okay, so the height of each bar is equal to its probability. So for example, we're finding the probability that exactly 2 out of the 10 use credit cards because of the rewards program, so it's highlighted in red. So the height of that bar is equal to its probability, so it's just underneath 0.2 or 20%. Okay, so we're going to round that to 3 decimal places. So it's 0.199 or 0.198. Let's go ahead and enter 0.198. And if it doesn't work, then the answer is 0.199. Okay, so the rounding does matter, right? So it's marking it as incorrect because we didn't round it properly. So it's round to the nearest thousandth. So when you round to the nearest thousandth, you're rounding out to 3 decimal places. So the three digits after the decimal point. Okay. So that 8 needs to get rounded up to a 9, because the next number over is 5 or higher. 5 or more, let it soar, so that you increase that number by 1. So it gets rounded up to 9. So the answer is 0.199. Okay, so be careful how you round, because it might mark you incorrect. Okay, so in part B, we're finding the probability that more than 2 use credit cards because of the rewards program. Okay, so it kind of tells you what you're going to enter. Right, so x greater than 2. So greater than 2. Click compute. So you can see in the graph that the bars highlighted in red, right, represent the outcomes where x is greater than 2. So that means 3, 4, 5, 6 on, all the way up to 10. Okay, so those probabilities are 0.62, 0.692, but to round it properly, that 2 gets rounded up to 3, so 0.693 would be the answer. Right, and then we want to find the probability that between 2 and 5 of the students will say that they use the credit cards because of the rewards program. Okay, so to answer that, you're going to select the between option on the calculator, and that'll allow you to calculate the probability between two numbers. Okay, so between 2 and 5 inclusive. So 2 goes here, 5 goes here, and then the probability goes here. Alright, and then the parts of the graph that correspond to getting between 2 and 5 successes out of a sample of 10, right, are highlighted in red here. Okay, so the total probability there is 0.818. Okay, and then that 8 there gets rounded up to a 9, so 0.819 is the probability. Okay, so that completes question 7. Okay, so let's look at question 8. And question 8 says that 79% of U.S. adults think that political correctness is a problem in America today. You randomly select 6 U.S. adults and ask them whether they think political correctness is a problem in America. The random variable represents the number of U.S. adults who think that political correctness is a problem. Right, so the number of adults are from our sample only, right, not for the entire country. Okay, so since we're looking at only 6 randomly selected adults from the United States, right, then the random variable will either be 0 or 6, or some whole number in between. Alright, we're going to answer the following questions. Okay, so the first part asks us to find the mean of this binomial distribution, so this is very clearly a binomial distribution, okay, so for the reasons we discussed earlier. Okay, so let's go to the book and see what it says about calculating the mean of a binomial variable. Okay, so that's what we're looking for. Alright, so we know how to calculate binomial probabilities. Alright, so how do we find the mean of a binomial random variable? Okay, and we're not going to worry about graphing binomial distributions. We're going to skip over that. Okay, so on page 209, you see the topic of mean, variance, and standard deviation. Okay, so the formulas here on page 209 are for the binomial distribution, right? So this is the mean, variance, and standard deviation. So remember, n is the number of trials, and p is the probability of success, and q is the probability of failure. So to answer questions about the mean, variance, and standard deviation of a binomial distribution, right, you need to know the value of n, p, and q. So for this problem, okay, the probability of success is 79%. Okay, so p is equal to 79%. And we want to convert that into a decimal, so you move the decimal point 1, 2 places to the left, or simply take your calculator, type in the number 79, and divide it by 100. to convert it into a decimal. So 79% of a decimal is 0.79. So our probability of success is 0.79. Okay, the number of independent trials, so the number of adults that we're asking whether they think political correctness is a problem, is 6. So n is equal to 6 in our problem. Okay, so using that information, we can calculate the mean. So according to the book, the formula for the mean is n multiplied by p. Okay, so we're going to do 6 multiplied by 0.79 to get the answer. And let's do that on our calculators. So 6 multiplied by 0.79 is 4.74. Alright, keep in mind that we may need to round that. Okay, so let's go back to the problem and see how we would round our answer. Okay, so we're going to round to the nearest tenth. Okay, so to the nearest tenth, right, this would be about 4.7. So the mean is 4.7. Right, so when you round to the nearest tenth, you round to one digit after the decimal point. Okay, so since it was 4.74, right, that 7 stays as a 7, so the next number over was a 4, right, so a 4 or less, let it rest, so that the number in the rounding position stays the same. Okay, next we want the variance, sigma squared. Okay, so according to the book, okay, the formula for the variance is n times p times q. Okay, so remember, for any binomial distribution, the probability of failure q is equal to 1 minus p. Okay, so q, which is the probability of failure, right, the probability that we get an adult who says that political correctness is not a problem is 1 minus 0.79. Okay. So remember, p and q are always expressed as a decimal. So 1 minus 0.79 is 0.21. Okay, so that's the probability that we get an adult who thinks that political correctness is not a problem. Right, and you can convert that into a percentage. Right, so it'd be about 21% of adults think that political correctness is not a problem. So q is 0.21 in any case. Okay, so for the variance, okay, so for the variance according to the book, right, it's n times p times q. So we're going to multiply all of those together, n times p times q. Okay, so n was 6, p was 0.79, q is 0.21. Okay, so 6 times 0.79, and then multiply that by 0.21 is our variance, which was 0.9954. Okay, and according to the problem, we're going to also round that to the nearest tenth. Okay, so that first 9 after the decimal point is in the 10th position. Okay, and the next number over is a 9. Right, 5 or more, let it soar. Okay, so what's going to happen is that 9 is going to get rounded up to a 10. Okay, so when you round that, okay, you're going to place a 0 in the 10th position and then carry the 1 over. Right, so 9 gets rounded up to a 10, so carry the 1 over. 1 plus 0 is 1. Right, so when rounded, this is equal to 1.0. So when rounded to the nearest tenth is 1.0. Okay. Okay, and then lastly, we want the standard deviation. Okay, so according to the book, the standard deviation is equal to the square root of the variance. So what you want to do here is take the square root of the exact number. So the variance was 0.994. So we're going to square root that number, okay, rather than the rounded answer. Right, so the square root of the variance is equal to the standard deviation. Okay, that's what you need to remember. So the square root of the variance is the standard deviation. Okay, so we're going to square root 0.9954. Okay, so we get 0.997. So when we round that, it's still going to be equal to 1. Okay, so the standard deviation is 1. Okay, so lastly, we're going to interpret the results. So most of the samples of 6 adults would differ from the mean by no more than 1. So we're going to put the answer for the standard deviation here, whatever it is. And that completes question 8.